It is often difficult to detect when a passenger has fallen or is behaving dangerously on an escalator, such as walking in the reverse direction. Detecting a fall on an escalator as it happens is an urgent problem to be solved to prevent further injury occurring from the continuous rolling after the fall, or the passenger's inevitable contact with moving parts. In a Moscow subway, at the side of the escalators, a guard box and operator on duty is set up. The operator observes the escalators and pushes the emergency stop switch immediately in an emergency. In China, temporary personnel are positioned at escalators during peak times when incidents are most likely to occur. It's questionable, however, whether these methods are scalable. Take, for example, the Shanghai Metro. With more than 4,000 escalators carrying more than 30 million passengers a day, it is not sustainable to have a manned operator at each escalator. This paper presents a practical method to overcome these difficulties, involving the use of real-time video monitoring analysis. Existing escalator detection systems are mechanical and rely on sensors attached to machines. They cannot identify problems with passengers unless and until they influence the moving parts. You can detect problems with passengers using a video, but it's not sustainable to have staff watching the use of escalators continuously. As a result, video tends to be more useful after an accident has occurred and is being investigated. Recent developments in artificial intelligence and image recognition technology has made possible new research in video analysis of escalator passenger behaviour. One study follows the use of the open pose key point detection algorithm and the support vector machine classifier to identify the human body structure, detecting a pedestrian fall event. One limitation of the algorithm is that it requires the detection of key points of the human body, which can easily be blocked by other passengers or objects, such as suitcases. The proposed method aims to achieve a high accuracy, low misjudgment rate, and low-cost real-time video method to detect passenger falls on escalators. The method extracts passenger motion based off the dense optical flow method visualized in the graphic. By tracking the pixels over 1 to 2 seconds, it is possible to determine whether a passenger in the picture is travelling normally, reverse walking, or falling. The calculation process is rather complicated, so I won't go into detail. However, if you're interested, I would recommend taking a look at the written paper where the mathematics is explained. With this system in place, it is possible to control the escalators remotely. Monitors are placed in the security monitoring room with an emergency stop button corresponding to the escalator system shown on the screen. The monitors display real-time video of the corresponding escalator. If the system identifies a dangerous event, it will alert the operator. The operator can manually confirm that the escalator information is consistent and will press the actual stop button if there's a dangerous condition on the escalator in the video. This will cut off the safety circuit to stop the escalator on which the dangerous event occurred. The proposed system was tested in Shanghai Metro Hanzhong Road Station, where the following results were collected. Over the course of a year, all 32 passenger falls and 738 passenger reverse walking events were successfully captured by 8 cameras corresponding to 19 escalators. An example incident occurred at 15:20 on the 17th of August 2018 on an up-running escalator. An elderly lady fell down after not holding the handrail. The operator in the security monitoring room was informed by the monitor of the incident and pressed the actual emergency button to stop the escalator immediately. The escalator was stopped 14 seconds after the fall, with the council arriving at the escalator 12 seconds later. The actions effectively prevented further injury of the passenger, greatly improving the safety of the escalator. The results from the station suggest that the system has a high accuracy and low misjudgment rate. It supports the idea that remotely stopping an escalator could be safe and convenient. The system has potential for wide application throughout the industry all over the world. Being able to remotely control an escalator significantly reduces the response time in the event of an incident, constantly reducing the risk of further injury from contact with moving parts.